Right, I've got two simultaneous equations here, but they are tricky. And the reason for that is because if I try to add them up or try to subtract one from the other one, like you do with linear simultaneous equations, the x squared and the x do not cancel each other out. So it can't be done by subtracting like you can with normal linear simultaneous equations. But so what you have to do is a substitution. So I'm going to label my equations 1 and 2. I'm going to rearrange equation 2, x equals 7 minus 3y. I'm going to substitute equation 2 into equation 1. So wherever there's an x, I write 7 minus 3y. It's x squared. So I have to square the brackets and then carry on. Now I have to solve this equation for y. So the first thing I have to do is multiply out the brackets. That's 49 plus 9y squared, and the cross term is minus 21y, but it's two of those, so it becomes minus 42y plus y squared. I'm going to move the 5 onto the other side, and then I'm going to collect up my terms. That gives me 10y squared minus 42y plus 44 equals 0. Now there's a factor of 2 in here, so I think I'll divide everything by 2, and I'm going to take it up to the top right now. So that's going to give me 5y squared minus 21y plus 22 equals 0. Now it looks awful, but let's just try and break it down a little bit. This bit, the constant value is the multiple of two numbers in the brackets. So where I have a y something and a 5y times something else, the multiple of these two numbers makes the 22. So what I'm going to do is list all the multiples of 22. That's it. Now, it's possible, it has to be possible, to add these numbers to make 21. But let's just think about it. If I just put 22 and 1 in no particular order, when I'm adding the y terms, I have to multiply these two and these two to add to make the 21. So I must make sure that I multiply one of these numbers by 5, and then I look at the sum, okay? And because this is a negative 21, they'll have to both be negative. Now, if I multiply the 11 by 5, I get 55, which is way too big. And if I multiply the 2 by 5, I get 10. And in fact, multiplying that by 5 gives me 10. And if I add the 11 on, I get 21. So I need to remember that I'm multiplying the 2 by 5. So in fact, I have to put it here, because then these two multiply. And I put the 11 in the other place. Now let's just check that that works. I've got 5y squared plus 22 minus 10 minus 11, and those two add to make minus 21. So now I have the solutions to the equation in y. Oh dear, I shouldn't have put that there. Let me just get rid of that again. So y equals 2 and y equals 11 over 5. Next, I use equation 2 again to work out x. So I substitute the 2 into the y here, and that gives me x equals 7 minus 3 times 2. So that gives me x equals 1. And on the other side, I get x equals 7 minus 33 over 5, which is 2 over 5. So my pairs of solutions are, this is one pair, and this is another pair of x and y solutions.